What is the today's project? Water level indicator. Why is that I brought first project is that for lot of practice. Okay, now why is that I made this project surrounding, everybody has got water tanks in up above the, but now what is the main problem these days that whenever the motor is on, we don't know whether the tank is full or not. So what happens is that a lot of times we need to go up and climb and then see whether the water is full or not. So usually grandparents are going to do this exercise. And when they are more than 50 under, what's happening? In the staircase steps are made, since they just slip and nothing like, after 50 years they don't, calcium also don't grow. So it's a permanent damage and we are losing grandpeople. Okay? So it's very risky also. Why is that we need to do all that if we have something else? And in my childhood, what is that I did, I have a LED, right? LED, yes or no?
Yes, sir.
I have a LED. I have a battery, suppose say 9 volt, okay? 9 volt battery. So, these two I took into a water level, tank, for example. Then what happens when your motor is on and continuously pouring water into the tank and the water comes and touches these tube sensors. Then the battery positive went into water and returned back through the water to the LED and the LED is returned back to the 9 volts. So if suppose the water is good quality and very, suppose it's salty water and all, the more current will go, the LED may go bad also. That's where we can put somewhere in between some resistance. Maybe 470 ohms or up to 1 kilo ohms, for example. Then in this case, whenever water touches these two probes, what's happening? The LED comes. And this is okay. When LED glows, we know inside that. So what happens, my dear friends? When LED glows, inside the
tank is full.
Oh yeah, we understand the tank is full. We can switch off the main motor. Yes or no? But this is what I did in my 5th class. Now, after that, it worked well for a month. After a month, it stopped working. My father said, "You made us full. You made something to work only for 1 month. You do something that again it works." I started breaking my head. Why it worked for 1 month, after that why it's not working?
The 9 volts battery is over.
I replaced it, but still the problem is continuing, not going. Then the water is coming up. Next. No, bulb is working. Bulb is working. Bulb is working. I replaced the bulb also.
Water.
Water? No, water is same water coming in from the same well. No change.
Why is that?
No, resistor not spoiled. That also is working. Which connection? You mean this connection? This connection is fault, or this connection is fault, this wire is fault, this wire is fault. None of these wires are fault. They are all working fine.
Under the water.
So the connecting point, because of the corrosion, because of the salts and fluorides in the water, these connecting things became bad. So they are not becoming good conductors. So whenever water touches them, the required current for the LED is not getting passed through the bad connections with the water, because every day they are in touch with the water and a lot of things are there in the water. They are all, corrosion taking place there, and after that they are becoming oxide because of the wires have got copper and all, no? So that because of copper oxide and all, we are becoming bad connectivity, so that the current required for LED is not getting passed through the points, open leads. That's where. So what I did, what is that I did? So simple. Cut it and again freshly open the new wire piece. So again it worked for 1 month. So every month my dad is doing this, but finally one day he told me, I can't do this exercise for every month. So you have to do something else. That is where I started thinking about what best I can do for this. How can I do something with very little current? Whatever little current is possible through this. at any time, even after 10 years also, whatever possible it will current. Even 0.1 milliampere should make my LED glow. Not only my LED, if I want a buzzer, because all the time these people keep on watching where is this LED. No, if the water is full, if the sound comes up, tomorrow make sure that buzzers are given to the children, okay? We will solve the buzzers also. You understand what tomorrow we will bring the buzzers, because I explained this, I will bring buzzers for you. Enjoy the buzzers also. So whenever water is full at the top level, what we need to get? Buzz, the sound, the beep, okay? So even buzzers require little more current. Even buzzers, not one LED, you need one LED in bedroom, one LED in kitchen, one LED in somewhere. Or not one buzzer in people common area, one buzzer in somewhere, suppose in some other floor. Also need to know, because today you will be in ground floor working, tomorrow you will be upstairs. So if this buzzer you don't hear in second floor, then if the tank is keep filling up, it's waste of water and precious water and power, yes or no? And if the water is not from the ground, if the water is from your sump, and if the sump water is wasted, then the next 2-3 days like Hyderabad you don't get water, then you are out of water in sump and then you have no water in the upside tank also. Yes or no? Precious, water is precious. That's where we have designed this particular small circuit for you. Now the circuit which I am explaining right now, because all circuit lab, children circuit lab, explaining circuits, interesting? That kind of difficult is what I think you need to sit here, because I think very fast the circuit you don't understand. Why don't you come and sit here? Why don't you use mics? Why don't you get out it here? Because there you don't properly see them. There are benches. Okay, you can see them. Now, see what is the modification I did, my dear friends. Now, another device called transistor. What is the device I am now introducing? A transistor. Very important device. So transistor has got 3 terminals. One is collector, other is emitter, another is base. So what we do with this transistor, I will tell you with the transistor how it's like, this is symbol. Like this is NPN transistor. N material, P material and N material. And that means 2 back-to-back diodes. Here, there are 2 back-to-back diodes. You can draw them, because usually you don't find them. So here is a P. This is anode. P. N. N. P-N junction is simple diode. P-N junction is a simple diode. So 2 back-to-back connected. That means anode to anode is connected back-to-back. So 2 diodes connected in that fashion is nothing but a transistor for you. N-P-N transistor. So whenever you want to test a transistor, you need to check the connection between this P to N and this P to this N. You need to check this diode working or not, this diode working or not. That is the way to check the transistor. I will tell you how to check a diode, then you understand how to check a diode. Suppose say, if you take only one diode, how to check this diode? As I told you, it must allow current only in this direction, not in the opposite direction. So what you need to do, you take the multimeter positive and keep on anode and negative on the negative, then your meter must show you the current flow. Then the diode is okay. And then if you reverse the multimeter probes on this diode, and if it is still continuing conducting current, that means diode is leak. Short circuit. It's no more working. So if reverse the bias condition, it should not show you any current in forward. So this is the same technique you need to apply to understand whether the transistor is working or not. Base to emitter is one PN junction, base to collector is another PN junction. So I will give you good exercise on transistor checking and all that, don't worry right now, okay, don't get confused. But right now, this is a transistor. Here what we do with the transistor, this is collector to emitter, it collects electrons from collector and it emits electrons from emitter. That means current will be received from the collector and sent out from the transistor from the emitter. So emitter is to emit electrons from the transistor. Collector is to collect the electrons from the other source. Okay. Now transistor as a switch. I wanted to say transistor as a switch.
What is the use of base?
I tell you. Just one minute. I talk this. A good question asked by our great friend. What is his name? Say again. Prithvi. Prithvi, you have a switch at home? Switch, electrical switch at home? Nanisha, you have a switch at home? So what you do with the switch? Come on, tell me fast. I'm running out of time. You make the circuit. You make the circuit on off, my dear friends. Here onwards, everything is circuit. No more fan, no more light. Light circuit, fan circuit, R circuit, pull off circuit. Our house itself is a complicated circuit. Right now, but maybe after this class they are no more complicated. They are just so smallest, easiest circuits. Yeah, that kind of circuits we will be building day by day. Okay. So, as we said, the switch is to do what?
It is to open the circuit.
Yes, close the, make and break the circuit. That's where you are using switch. Careful, observe. Vinita. I am giving a big exercise to you. Why is the transistor required for us? Okay? And the base of the transistor is very much required for us. That's the important question asked. Well, hey, listen, boys. You have a switch to your light circuit in the home. How many times per second you can make and break the light circuit? Six. I wanted to make sure your light is on, off. In my childhood I used to play. Nanisha, you don't know my childhood in 7th class. Running lights are running lights. Running lights అంటే అవి ఏదైనా పెళ్లి జరుగుతున్నప్పుడు ఫంక్షన్ జరుగుతున్నప్పుడు అవి లైట్ డెకరేషన్ పెట్టేసి పెద్ద పెద్ద బల్బులు అవి పిచ్చి పిచ్చిగా దంతులు వేస్తూ ఉంటాయి, రన్నింగ్ చేస్తూ ఉంటాయి. కొన్ని కలర్లు ఎలా వెళ్ళిపోతుంటాయి, కొన్ని అట్లా వచ్చేస్తాయి, కొన్ని ఇట్లా ఏదో డిజైన్ బాగుంది డిజైన్. చూసావా, నాకు చిన్నప్పుడు 7th క్లాస్లో ఆ ఇంట్రెస్ట్ వచ్చింది. హౌ దట్ రన్నింగ్ లైట్స్ వర్క్. I started understanding how the design comes out, who is controlling, who is giving the design in the lights. No, you might use this no question. Okay, so ultimately there are some particular lights, they are called serial lights. Small bulbs, 100 bulbs in series connected, so directly they can connect to 20 volts. They are called serial lights. చాలా అందంగా ఉంటాయి. ఆ సీరియల్ లైట్స్ డెకరేషన్స్లో బాగా పెట్టేవారు అనమాట. మంచి అందం వచ్చారు, పందులు వేయడానికి వాటికి పెట్టారు, చాలా బాగుంది. సో అందులో కూడా రన్నింగ్ పెట్టారు. తర్వాత అడిషనల్గా ఇంకేం చేశారు ఆ సీరియల్ లైట్స్లో? హ్యాపీ ఇన్ఫ్యాక్ట్ ఇన్ మై దట్ పర్టికులర్ టైం ఆ సీరియల్ లైట్స్లో ఆ లైట్స్ ఫ్లిక్కరింగ్ అవుతున్నాయి చిన్నప్పుడు. So one day suddenly I got a doubt, like how these lights are flickering and who is making the switch on off continuously for so many times per second. That is the question in my mind. Then suddenly I started tracing the serial line connections of that particular one marriage party. Of course, that day whole power has got tripped for them. That's a different scenario because I'm trying to figure out all these things. They never know that I'm going to short their cables and all. Okay, I got shocked and then I just messed up all the things, and after that, because the day before they set up everything, and so that day then when the marriage activity is going on, in middle of it, I did all this mess up. I did a lot of these activities right now. Okay, now finally what I wanted to tell you about, who make them flicker, and that too so fast, every second maybe more than 100 times. That's where we are finding the joy. Okay, my dear friends? That means ultimately I came to know when continuously light is glowing, that is not fun. When it is flickering, it is fun. When it runs, it is more fun. In changing its color, it is much more fun. These are the areas I really enjoyed and started understanding them. Finally, yes, I am thorough and clear about it. My dear friends, why Ruthvik asked this question? Ultimately, today what I wanted to tell you, suppose say, if I want to make one light on off, how many times you can keep on off for that bulb in a second time? Time given to him is second. In 1 second time, how many times you can on off the switch? One time, no. 4 times reasonable. Next, I tried my level best up to 7 times. Beyond that, I could not. No. I would not do that. But that is where it is happening there, maybe 100 times. Then only the fancy has come there. But who is doing that? This is a question in my mind at that time. But at that time, that microcontrollers are not developed much. That's where they are using one tube light starter in series, so that is making the flickering. Number of times make break. So all these lights are make break. Okay? But now the question to you that running and all is different. There's a drum running with motor, all the electrical connection switches are getting closed in required design format. From there they have connected the given phase to this, and the connected phases are to all the different colors of the lamp series. So as the design made on this drum, according to that the connections were made, and then the outside the lights are colorfully dancing like whatever we want. So entire control is made on a drum, a wooden drum, on which copper connections are made. So as the drum is rotated at required speed, changing the speed and all, according to that the connections were also changing. According to that the outside lights, lamps and the colors are altering. That's all stupid electricity. Electrical connections, not electronics much desired. So now this is the device, that transistor is a device. Collector and emitter are switch connections. I gave you switch, no? Switch is there with you. So it has got two connections, right? Similarly, the collector and emitter are two connections. But however, to make this switch on, what you need to do, my dear Shravani?
You have to connect the battery.
No, you have to press the force, apply the force and make the mechanical connection on. Then only the electrical connection is on for you. So whatever power you give on one pin, the other power will come on the other pin, right? Then you can further drive your circuit. Similarly, like the two connections what you have on the switch, those two connections are there on this transistor called collector and emitter. But there here you are applying your force with your finger, yes or no? But there in the transistor, the same kind of thing is done with the base. So if you give a signal on the base, then this are you following? The switch connections are getting closed. Make and break is taking place. That means if the base signal is given, if any signal is given at base, this is on. So whatever power you give, the power will come here. Circuit is closed. The switch is closed. When you remove this base signal, that is open. Because you see the switch also has got two sides, no? One is on and the other is off. Similarly, if you apply base signal, this is on. Remove the base signal like this, that is open. You understand, my dear friends? So when I understood this basic in my 7th class, that's it. That day itself, I started using this transistor as a switch, as an electronic switch, because physically I am not going there and applying my force on the switch. Just I am sending a signal from somewhere very far up through a cable. Signal, electric signal from somewhere, I am sending a small signal. With that small signal, what happens is that collector to emitter is closed, that make and break is opening taking place and all. So I can make the circuit or I can break the circuit from far off place. Now here is the toughest question for you. Toughest question. In my childhood, when I have this question, maybe in 6th class. What is the question, you know? If I switch on electricity in cable here, what is the time it takes to reach after a kilometer? After 10 kilometer? After 100 kilometer? Somebody think about this. Wonderful question. What is the question? I have power here. Suppose 9 volt positive is there with me here. I have wire, whatever kilometers you want. I can have wire, no, not a big deal. No? So after 10 kilometer, I have a bulb and cell phones are on. My assistant and myself are on with cell phone. And I said, yes, switch on. Then after how much time he will say, yes, the bulb started glowing. What is the time taking to make this cube? You switch on and see the bulb is glowing. How much time it takes? That is a question given to you, my dear friends. Come on, fast.
1 second.
Not 1 second.
A few microseconds.
More than? No, not 1 second.
Few microseconds.
Why microseconds? Good answer, microseconds. Why microseconds?
Because electrical current can flow very fast through the conductor.
What very fast? I don't listen. I don't
The electrons
like
in it.
answers. I want accurate answers. This is practical session, not regular theory session.
the electrons in the wire will be flowing so fast.
Tell me.
The electrons in the copper wire will be moving so fast by attack.
This is also generic answer.
So there is no resistance opposing it.
Think that my cables are very low resistance. So you don't have to really bother about the resistance of the wire. That much low. That means huge cross-sectional areas. My conductor has got. And with very little voltage, that the resistance really doesn't much. And that to the load what I have there may be LED with very mildly ampere current. So resistance doesn't really feel like in between the cable. See, this is what you really missed. It's going to be given homework for you again for today. What is that point? You know that. How much time it takes for 1 kilometer, 10 kilometer, for 100 kilometer. This is to be answered tomorrow. Think about it. Ask all your friends. These are not given in the books. Live experience. Yes or no? I'm happy about this class. Anyway, now let me show that water level indicator circuit. One stage explained, all 3 stages are remain. Ultimately, my goal on building this project for you guys to make you understand particular the function, basic function of water. Now I have here a water level, water tank. Okay, I have here one water tank. I have here one water tank. I wanted to understand the water in 3 levels. One is at reservoir level, one is on reservoir level, one is at mid level, one is full level. I need to know 3 levels of the water. When the water is full in the tank, I need to see all 3 lamps are glowing. When water is less than full and more than 50%, then I need to see 2 LEDs, red and yellow is on. That means I know for sure the water is not full because green is not glowing. But however, it is more than 50% because both are glowing. If it is less than 50%, only the red will glow. All 3 stopper means no water at all. Okay, my dear friends? So, red is to indicate reservoir level, yellow is to indicate medium level, green is to indicate all full, so that you can switch off the motor. And you can switch off the motor only when if the red is glowing, none of them are glowing.
So you can place even buzzer.
You can keep a buzzer across the LED, green LED. Then whenever water is full in the tank, automatically buzzer will come. Okay? So now I will show you the conditions. Okay? Now we know this. And how do we control that with the circuit? So I will explain one stage of the circuit, rest 3 are similar. Okay? I have here one particular positive 9 volt battery, one switch connection, 9 volt switch connection, and 9 volt battery. Okay? And this is the negative of the battery. And from this, I have one reference to the battery. Okay, 100 ohms. This is 100 ohms value, one reference. And from this reference, and the red one, I am taking the red one, okay? And this is the 390 ohms coming up, and to the transistor base, and for the 1 kilo ohm resistor to limit the current for the LED. So here is the LED, and this is 9 volt negative. So I don't want to just jump the cable and connect. So if I just show you like this, that means these 2 are connected together. Okay. Okay. Now listen to this. This is 1 kilo ohm resistor. Okay. And this is our red LED. Okay. Red LED. And this is our 547 NPN transistor, collector, emitter, and the base. This is NPN transistor. That means whenever the base is positive and then the collector is connected to emitter, so that the 9 volt through the 1K and to the LED and then to the collector and the emitter, circuit is closed. When circuit is closed, this will start slowly. Okay, understand? Now, what is that I am going to show you here? Here is my water tank. Here is my water tank. So, in this water tank, what's happening? So the reference, the 9 volt reference directly went into the water. 9 volt reference, 9 volt is here. Once you switch on, all this is 9 volt. Okay, 9 volt, 9 volt. So once you switch on the 9 volt through 100 ohm resistor, it went into the water. So when motor started putting the water inside this tank, then automatically the water will come and touch this. Because the level of the water comes up, no? Yes or no? Once the level of the water comes up, it touches another wire called red wire. Because we gave you 4 different colors. This is the red wire. From here to here, this is the red wire. Red wire. So the piece of the red wire, when the water level touches, oh, this is the blue wire. This is the blue wire. So blue wire is the reference one, which is going here. This is reference, REF. So reference is always kept in the down to the water level, water tank. And from there, the 9 volt through the 100 ohm resistor is already there in the water. And when the water touches this particular point, and the 9 volt connection comes into this, and through the 390 ohms it goes to the base, this transistor is getting dry. When it getting the base positive dry, immediately this is on. When it is on, like suppose, where is your switch? It is something like this. This transistor, nothing to worry about it. It is just nothing like this. See, these 2 connections, we forget about all these transistors, that's just nothing. Whenever the water level touches, automatically someone has come here and pushed. When it is pushed, these 2 are on. When these 2 are on, 9 volt to the resistance to LED and ground, what happens? LED glows or not? Tell me. Similarly, whenever water touches the red wire, immediately this is on. Whenever somebody started using the water, when the water level go down without touching this cable, this is stopped. That means no water in the tank. Okay, similarly, now the same circuit, no change, is here for another yellow wire, from here for another green wire, the same circuit. I'll give you one paper, circuit paper, don't worry. Then what happens? Whenever the water comes here, this circuit is also on and yellow light is also coming. Whenever waters go furthermore and green line also got signal and the green LED is also coming up. That means when all 3 are glowing, water is full. The last green also glowing means because the connection for green lamp, we have taken it from the topmost level of the water tank. Then what happens? What it indicates? Water is full. That's where the 9 volt reference from the water, it also touched this point. From this point, green also started glowing. Then automatically you understand that water is full in the tank because all 3 are glowing. Suppose now, when this is the green also is glowing, what we did is just simply switched off the water. Started people using different people at toilets and bathrooms and kitchen, and people started using water, right? Yes or no? The level will go down. That means after the level comes down here, then what happens? Green stops. Because green is not getting connection from the reference 9 volt. So green light doesn't come. Then after some time, even the water level is below this yellow connection. Then yellow also stopped. When yellow also stopped, that means the water is between half to 0. Then red also stop means what? There is no water because the reference 9 volt is there in the tank, but it is not getting to any of the probes, yellow probe or red probe or green, no probe, nothing, no connection, no LED is glowing. Okay, my dear friends, is it simple or not? Tell me yes or no? Yes. Now, shall we solder this and make sure the works right?